All right, eventually we're going to have other exponential functions, but for right now, we're going to limit ourselves to a times b to the x, where a is a positive number, a is it's called the initial value. If x is 0, b to the x is just 1, so you have a times 1. B is growth or decay, so let's just say growth, if b is big, b greater than 1. Decay, b between 0 and 1. We are not going to use negative numbers for a or b at this point. Okay, weird things happen when you start worrying about negative numbers. Okay, growth or decay. Again, you look for the thing that's stuck to the x. So that's the b. Okay, and a is whatever you're multiplying, the constant you're multiplying by. So a is 3 in this problem, b is 2, b is bigger than 1, so this is growth. Okay, a is 1/2, b is 2, still growth. A is 2, b is 4, growth. A is 3, b is less than 1 this time. A is not 5, a is 2. Be careful. A little note, I didn't include one of these, but if you don't have a number that doesn't have the exponent, then a is 1, just to remind you. Okay, so for this one, we can actually tell what b is if we're really careful about looking things, but a is really easy to tell. A is the initial value. So a is 4. This one is a growth function. And in fact, I'm going to just say that this particular one goes through 0, 4, but then it also goes through 1, 8. So b is what you're multiplying by each time. I didn't ask the exact value for b because it can be very difficult to see on the picture. So let's just notice that b is greater than 1 when we're growing like that. Here, a equals 3, and this is a decay because it's going down. So b is less than 1. We're not allowing it to be negative, so write it properly. Last but not least, how do you tell the difference between a linear or an exponential function? Linear functions add or subtract. And of course, subtracting is just adding a negative number. The slope is the rate that you're increasing by. Exponential functions, you're multiplying or dividing, but we can say dividing is multiplying by a fraction. So what we look for is, do we keep adding the same amount each time? Well, clearly not. Are we multiplying by the same amount each time? Yes. Here we seem to be multiplying by 3 to get from 7 to 21 to 63. Is that still true over here? Sure. 7/3 times 3 is 7. So B is 3. This is exponential. So what is A? A is the y-intercept. What's the y-intercept? Okay, it's the value when x is 0, right there. So the equation is, the function is f of x is 7 times 3 to the x. All right. This one, are you multiplying by the same amount? No. But we're adding the same amount. In fact, we're adding a positive number because it's getting less negative. N is the slope, it's the rate of increase. We're adding 1/2 at a time. So we have y equals mx plus b. I would like to point out that this is a different b. It's the old-fashioned y-intercept b. Oh, look, there's the y-intercept. Where? Well, when x is 0. Okay, so y equals, the slope is the rate of increase, and the y-intercept is where you hit the y-axis when x is 0. And I don't care if you write plus -3 or just subtract 3, frankly.
And I also really don't care if you write y equals or f of x equals.